So let me go ahead and start sharing my screen and we can begin. Okay, so volume of prisms. So here are some words we're going to look over. A lot of this are reviews, but we will again look at edge, lateral face. We're going to look at oblique prism. We're going to look at right prism, which is new, and volume, which is obviously new. So we have about 3 new words that we're going to look at today. Let's go ahead and dive in. So let's just do a brief review of prisms. So prisms are 3-dimensional solids that have 2 congruent bases and the same number of lateral faces as there are sides of the base polygon. Well, this is something new and something we can use to our advantage. So what it's saying that the number of lateral faces is equal to the number of sides. So for example, here we have a triangular prism. What we'll notice is there are 3 sides on the base. 1, 2, 3. And what this is saying is that from that, what I can gather is that I'm going to have 3 lateral faces. If I have 3 sides of my base, then I'm going to have 3 lateral bases. So that's something unique we can look at. So depending on the number of sides of the base, that is equal to the number of lateral faces I'll have. And so for example, the lateral face would be this one on the bottom, and this one. And so there are in fact 3 lateral faces. Okay. And of course, our bases are congruent, 2 congruent bases. What we know about prisms is that our prisms are named after the type of base we have. So this would be a triangular prism because the base is a triangle. A right prism is one whose lateral face are perpendicular to the base. So a right prism is one whose lateral faces are perpendicular to the base. So, for example, if I had this lateral face, if I looked at this one in the back, that is perpendicular to my front base right here. And so that would make this a right prism. Okay? That is what that is saying. Okay. Prisms are named by their base shape. We just discussed this. So the base shape of this prism on the right side are triangles, and so this would be a triangular prism. The figure is known as a right triangular prism, obviously because the base and the lateral face are perpendicular, and because its base is triangular, so a right triangular prism. It's a right prism because we can see that it has a lateral face that are perpendicular to the base, and we can also call this a triangular prism because the bases are triangles, right? So just overviewing that. There are rectangles that form the lateral faces, and we saw those rectangles. We have JMKH, MLIJ, and ILKH. And so those are just the lateral faces. So just one more time, let's go over this. Our bases are going to be these right here, these triangles. Those are our bases. The lateral faces are going to be what connects those bases together. So we have 3 rectangles. Okay, so just keep that in mind. Okay, so now we're going to look at how to find the volume of these things. Well, volume is the measure of the amount in space occupied by a 3-dimensional solid object. So basically the inside part, that would be considered our volume. To find the volume of a right prism, the first thing we want to do is find or identify the area of the base. So in this instance, the area or the base would be these 2, the top and the bottom. And so we want to find the areas of those bases. The reason being that the area of the bases tell us how many square units can fill the base. If we fill the entire base with units cubes and then stack more layers on top, you can do that h times, which is the height, and that will give you the volume. So let's put this into practice. Basically what it's saying is the first thing we want to do whenever we're trying to identify the volume is we want to identify the area of the base and then multiply that by the height. So volume is equal to base times height. We want to find the area of the base. So for example, here we're given our base. We're told our base is 16. We can plug that in. And this would represent our height, 20. And that would equal to 320. So that would be our volume. So the first thing it did was B is relevant or tells us the area of these bays. And H tells us our height. Same thing here. We're given our base. This would represent our height. Whenever we're getting height, height is going to be the height of the lateral face. So we're not looking for the height of the base. We're looking for the height of the lateral face. So volume equals base times height. The base is 14. And our height is 15. Multiply those together, we get 210. Okay, so that is our equation for volume. 1 second. But what exactly are we doing? Well, what we're doing is we're looking for our base. So we're looking for the area of our base and then multiplying the area of our base by our height. So here, we're not given B, we have to look for it. Again, B is going to be equal to the area of our base. And H is going to be the lateral height. So, first thing we want to do is find the area of our base. Well, what we'll notice here is we have a triangular prism, and so our base is a triangle. What equation do we use to find the area of a triangle? We use 1/2 the base times the height. Okay, so I'm plugging that in. B is my base, which is 2x in this instance. My height for that triangle is x plus 1. Right? And so I can go ahead and simplify that. First thing I'll do is I'll distribute these over. Then I'll distribute this. So I'm just simplifying. So there is my simplified version of my base, or the area of our base. And now I want to identify the height. Remember that I want my height to be the lateral height. So the height that is available for my lateral face, this is my lateral face. And so the height is going to be x plus 3. So height is equal to x plus 3, or x. Trying to see. I think it's x. So my height is x, actually. This is my height. That is my length of my lateral base. That was my fault. So this would represent my height right here. X. Now I can go ahead and put those together. So I'm going to put volume is equal to my base, which we just identified is x squared plus x times x. Okay, now I can go ahead and simplify that by basically distributing my x over. x3 plus x squared. And so that would be my equation to find my volume. Basically, the first thing I did was I identified the area of my base. Then I identified my height, and now I'm putting that together to create my volume equation. Well, I'm not getting given any information about x, so I can't solve that. But if I were given information about my x, for example, if x is equal to 2, now I can go ahead and solve that. So this is the equation we found for that volume. And now x is equal to 2, so I'm just plugging in 2. 8 plus 4, my volume is equal to 12. Okay, so that is how we find the volume of a prism. The first thing we look for is the area of the base. And then we go ahead and we look for the height of the lateral face. And then we multiply those together. Now this changes if we do not have a right prism. If, for example, we have an oblique prism, it's going to be a little bit different. So what is an oblique prism? An oblique prism is a prism whose lateral faces are not perpendicular to the faces. That being said, the height of the prism and the edge of the prism have different measures. to find the volume of an oblique prism, we use the same formula that we would use to find the volume of the right prism, but in this time, our height is going to be this height right here. It's not going to be the height of our lateral face or the edge of our lateral face, the length of the edge of our lateral face. It's going to be the height on the inside because our lateral faces are not perpendicular to the base. So the height of this prism would be an altitude. So I'll show you what this looks like. Here it says, a piece of crystal is cut into an oblique rectangular prism with these measurements. What is the volume of the prism? But we know that the volume is equal to the area of the base times the height. But in this instance, our height would be equal to the measure of this line segment because we have an oblique prism. That being said, here we have some information. We're told that E and S is equal to 6. R and E is equal to 8. Z and D is equal to 14. And C and S is equal to 15. Well, the first thing I need to do is I need to identify my B, the area of my base. This is my base. So I have a rectangle. I find the area of a rectangle by taking length times width. So length times width, 6 times 8, 48. So B is equal to 48. Now, because I have an oblique prism, I need to take the oblique height or the altitude as my height. That means I would use this height, 14. I wouldn't use this height because I have an oblique prism. If I have an oblique prism, then I'm going to use the height of my altitude. So I'm not going to use the height of my edge like I did when I had a right prism. So now I have 48 times 14, which is equal to 672. So that would be the volume of my prism. Please remember that when you're finding your B, you first want to find your B is equal to the area of the base. You use whatever equation you need for that area of that specific two-dimensional figure. So because that rectangle, or because that base was a rectangle, I'm going to use length times width. Over here, that base was a triangle, so that's why I use 1/2 base times height, because that's the area of equation for a triangle. So you're going to use the equation for that area of that 2D figure to find the B, the area of the base. And then because here you have an oblique prism, you're going to use the altitude height, the 14, and then multiply those together. But here we'll go over another example. It says, in this oblique rectangular prism, and it gives me these different sides. What is the volume? So we're looking for the volume. So volume is equal to the base times the height. My base here is this bottom half. And my height, I can do it like this. My height is going, because it's an oblique, it's going to be the measure of this altitude. So first thing, let's find the area of that base. Let's see what we're given. ZT is equal to x minus 1. ZD is equal to x minus 2. ZC is equal to x, and BC is equal to x. Well, this base is congruent to this base. We know that. Our two bases will be congruent. So I can use the information about this base to solve for the area of that base. Remember that the area of a rectangle is length times width. I know I have an area of a rectangle because it is a rectangular prism, and my prisms are named after their types of bases. So that'll give me x times x. What about my height? Am I given any information about my height? Well, again, I have an oblique prism. So my height is going to be, in this instance, Z and D, which is equal to x minus 2. And so now I'm multiplying those together according to my equation for my volume. This gives me x2, x minus 2. Now I can go ahead and put this inward to multiply. X3 minus 2x2. So that would be the volume equation for this oblique rectangular prism. One more time. The first thing you want to do is identify your B. Your B is going to be equal to the area of your base. The area equation you use depends on the type of base you have. If you have a rectangular base, you use length times width. If you have a triangular base, you use 1/2 base times height. We have different area equations for different types of 2D figures, so make sure you're using the correct one. Next thing, you want to find the height. Because this is an oblique prism, we know that our height is going to be equal to our altitude. And in this instance, our altitude is x minus 2. And so now that I have both of those, I can multiply them together and find the equation for my volume. Does anyone have any questions here? Questions, concerns? No? So let's go ahead and look over some examples really quick. Okay, so I have a cube. And this is a right cube, okay? That is such a bad, I can try better. Dang it, okay, hold on. Okay, so I have a cube. I know that this line segment is equal to 2. This line segment is equal to 3. And then my height is going to be 5. So now find the volume. Well, first thing I want to do is find the area of my base. So length times width, because I have a square. 3 times 2, 6. Now my height is 5. So now 6 times 5 is 30. Remember that you want to find the area of your base and then multiply that by your height. Now, hold on guys, give me 1 second. Okay, aquí está donde. Sí, mija. Hold on, guys. 1 second. Muchas gracias. Con permiso. Okay, sorry about that, guys. Okay, so now, okay, so now I have that same cube, but this time it's an oblique cube. So oblique, I don't know how to draw it. Say this is the altitude. Okay, so then I know that this is equal to 7. I know that this is equal to 3. And I know that my altitude is equal to 2. Okay, so now I want to find my volume. First thing I want to do, identify my base. For a square, it's length times width. So 3 times 7, 21. My height, because it is an oblique, I'm going to use the measure of my altitude, which in this instance is 2. So times 2. So 21 times 2 will give me my volume, and that is 42. So that is how you will solve for this. If for some reason my base was a different figure, for example, it was a triangle, say my base is a triangle, then I would use the area for a base equation. area for a triangle equation. I wouldn't use length times width. Instead, I would use 1/2 base times height. Okay, so that is how we solve it. That's not what I meant to do. Almost done. I'm just reviewing now. Okay. So here's just information about the right prism versus an oblique prism. For a right and oblique prism, both of your bases are going to be congruent to each other. Keep that in mind. The number of lateral faces will be equal to the number of sides for both of them. However, in a right prism, your bases will meet at right angles. We saw that our base with our lateral faces meet at right angles. In an oblique prism, however, they do not meet at right angles, and that's why we need to use the altitude. And then our lateral face shapes of right prisms will be rectangular, or in oblique prisms, they will not be rectangular because they're not perpendicular. But for both of these prisms, volume will be equal to the base of the base area times the height of the prism. So here's just one more example. It says Caitlin is conducting a box in the shape of a rectangular prism to hold her lab supplies. To sit on her locker shelf, she needs the base of the box to meet 6 inches by 5 inches. If the box must be accommodate 90 cubic inches, how tall must it be? So I want to identify how tall or what the height of my box must be if I know that my volume is equal to 90 cubic inches. Well, I know that volume is equal to base times height. So I have 90 is equal to base times height. How do I find my base? Well, it's equal to the area of my base. So this is a rectangle, so 5 times 6, length times width. My base is equal to 30. And now that will help me identify my height. So I just divide by 30 on both sides. So my height is equal to 3. So I can work backwards to identify my height if I'm given my volume and I'm given information about my base. So that's what I'm basically doing here. And this is what we'll get into on Monday, but does anyone have any questions right now? No? Okay. If there's no other questions, you guys may log off and I'll see you guys on Monday. Bye, guys.